Hello, I'm Francois Zimmerman, and today I'm going to look at overcoming bias using visual analytics. Why is this important? We believe that when businesses make decisions that are biased, that results in reduced competitivity. And when this happens at an individual and institutional level, that results in a range of social harms from, for example, discrimination all the way through to measles outbreaks. So today I'm not going to focus on biased decision making which results from gut decisions. I'm going to look at places where the data is available, but we fail to see the real truths due to human limitations. When we look at large, complex data sets, we tend to, for example, when we have a lot of data points, we look at the averages and ignore the outliers. When we have information that spans a long period of time, we tend to zoom in on a point in time and lose the context that's encoded in the development history. And finally, I think most importantly, when we have a lot of dimensions and measures in a data set, we tend to cherry pick the measures that suit our bias, and that's when motivated reasoning starts to creep in. So today I'll look at 6 visual analytics techniques that can be used to reframe our perspective on a data set so that we can continue to revisit it and challenge our initial interpretations until we arrive at deeper truths. So to explore the impact of bias, I've recreated this illustration from Hans Rosling's amazing book, Factfulness. He actually uses this to explore this kind of us and them view of the world, where we divide the world up into developed and developing nations. And he actually uses this to show the fact that this is actually based on a 50-year-old data set and that our worldview is woefully out of date. But I'd like to explore bias thinking by looking at this in a little bit more detail and look at whether or not these two boxes, developing versus developed, on this particular data set are actually accurate, or whether they reflect biased thinking. So this data set shows 2 dimensions. It shows babies per woman. Towards the left, you have larger family sizes, and it shows children surviving to age 5. So as you get to the top of the chart, you see better health outcomes. And at first, it looks fairly accurate. It looks like we've got 2 big boxes, developing and developed. And this is the way that we interpret the world when we look at the data in kind of static images that are embedded inside a PDF, or static images that are embedded inside a presentation. These annotations become immutable. We can't really question them. What's more important is the value judgments that become immutable. So in this chart, we can see these 2 annotations: big families and many children die. So somehow it's inevitable that in these developing world nations, we have larger families. There are always going to be worse outcomes, and that is somehow inevitable and unavoidable. When you look at the data and you look at these 2 boxes, it's possible that they're not really all that accurate. So the first thing I would do whenever I see a manually drawn cohort like that, this manually drawn cohort developing versus developed, I would test that by overlaying machine clustering. So in this case, what I'm going to do is I'm going to create some k-means clusters using Tableau to essentially pull apart the data a little bit. And what I see immediately is I see actually on the left-hand side, instead of 1 cluster developing, there's actually these 2 clusters. So cluster 4 here, the nations shown in green, we can see that there's a high number of babies per woman, and actually there's very poor survival outcomes. But cluster 3 have roughly the same family sizes, but you have much better health outcomes. So I guess the first insight really is how accurate is it to group, for example, Mali, where 40% of the children die before age 5, alongside Jordan, where less than 10% die before age 5. Is that first box that we saw, is that accurate, or is that an indication of some biased thinking? Now, for me, what's interesting about this concept of computer-generated clustering is this corresponds more closely to the way the World Bank views the world today. They no longer really use the terms developing and developed. They actually analyze the world in terms of continuum of 4 income bands, and they see it more as a range from income band 4 all the way up to income band 1. That's quite interesting, because once you've seen those clusters, you really can't unsee them, and you really start to question whether or not these original boxes were accurate, or whether or not we can come up with some sort of better categorization. So that's the first technique, using k-means clustering to challenge these manually drawn cohorts. The next thing I would do with this data set is I would bring it up to the current point in time. So I would do data analysis over time to see how those clusters and cohorts kind of develop as we roll forward. And actually, the first insight you get here is that cluster 4 disappears entirely from view. And the next insight is that if there ever was a strong divide between the developed and developing nations based on these two data points, that has largely disappeared from the view. So looking at data over time, looking at the broad trends, gives us those immediate insights. So the next thing I would do is I would spot test my hypothesis by looking at the entire development history of some specific countries. So if I'm trying to test what is the correlation between babies per woman and children surviving to age 5, what I'll now do is I'll drill into the development history for a couple of specific countries. When I look at India, for example, there appears to be a really strong correlation. There's this diagonal line going from 1969 all the way up to current. But when I look at other nations, that doesn't necessarily hold true. In Afghanistan, for example, you can see that the health outcomes improve dramatically before number of babies per woman starts to fall off. And the other thing that's kind of valid about this point of view is you don't lose the really important contextual details from specific outlier points. So, for example, this is Haiti. In 2010, you can see the dramatic impact that the earthquake and some subsequent cholera outbreaks have. And actually, this is really important because it shows to me that external factors have a huge impact on this. And those external factors aren't captured in these two data points that I've selected. So this brings me on to an important point, which is that if I'm selecting metrics, I need to be honest with the people that are consuming my visualizations about what other metrics are there, what metrics haven't I selected. So I think it's important to expose the metadata behind each data set to the consumers. In this case, what I've got here is I've created a view. These are the other world development indicators that I haven't selected. This data set actually contains more than 1,900 data points per country per year. And they span topics from economic policy all the way through social protection and poverty and so forth. Now, for these initial two cheat sheets, I've chosen two metrics from the health categories. I've chosen mortality rate, and I've chosen fertility rate. But a person with a different domain of expertise might, for example, want to look at gross national income, and they might want to be able to explore what data sets are available and what is the quality of each of those. So here, this visualization shows me what is available by looking at the metadata, but it also looks at the data. So it shows, for example, this one with the short bar over here only has data for a couple of points in time, 2016 and 2017, whereas this data set down here is probably of higher quality for my overall analysis because it contains data for a lot of countries over a long period of time. So now that's pretty useful because people can look at the metadata and they can discover other measures which I've potentially excluded from my initial model, and they can bring their own area of domain expertise to discover something that might be more relevant. So what I've done is I've created a view which enables people to quickly correlate any two measures. So in this case, I'm going to quickly switch my perspective to look at gross national income per capita. And the model then I can play through the model over time and I can see how those two measures correlate and how they develop in context. So I think that's pretty useful. But there's another thing on this view which is some potential bias, which I just want to draw your attention to. So in this case, I've got this trend line, which is not a particularly good fit. It's a 71% R squared, and it's showing essentially what is the relation between fertility rate and mortality rate. And often trend lines in themselves can create unconscious bias. So what I've done is I've created this view, which is essentially a view of the residuals behind the trend line. And now when people are exploring data as it relates to the trend line, they can also look for artifacts that might indicate, for example, missing data or just a bad fit to the model. So in this case, there's actually quite a lot of missing data. You can see all these data points that are on this diagonal line and the data points that are on the y-axis actually are where there's either zero or null data filed for the countries. Now that in itself is a useful perspective because it might force me to select some different measures, or it might force me to update my worldview. So the final technique I'd like to look at is part-to-whole analysis. So how do I compare a particular data point in one country to all of the other data points that I've collected for all the other countries around it, and also how do I compare the development of a country over time to what is happening with other countries at specific key points. So in this case, what I've done is I've created two visualizations. The visualization at the top here is essentially a heat map. What are the data points, all of the data points that I've connected per year, and then what are the quartiles? How do those break down? So I get a good perspective of the outliers as well as the general trends. Now, what I can do with this is I can overlay a specific country over that and see where does that fit in context to all of the rest of the countries around it. And when I do that, I really see, for example, how much of an outlier this data point in 2010 in Haiti actually was compared to all of the rest of the countries around it. So I can see Haiti's development over time here, and then this data point relative to all the other countries in terms of what their development indicators were looking like in 2010. The other thing is, because I'm not losing any of the granularity, I get to expose some specific truths that didn't really come out before. So if I look at, for example, life expectancy, and I compare that to gross national income, I can see these very big loops that come off the bottom of this heat map. So these loops are effectively, this one on the left-hand side here is essentially Cambodia, and you can see very clearly the impact of the Khmer Rouge. You can see that life expectancy drops to under 20 years. This didn't come up in any of my scatter charts because the data for gross national income isn't collected for that country at that point in time. So authoritarian regimes are not great at collecting economic data. And so the only way I'm going to get that is by preserving the context on these heat maps. So today I've looked at 6 methods to challenge bias and to essentially reset the perspective on a data set so we can discover new insights that we didn't really see initially. These only become possible when you move from static views to publishing essentially a model showing your findings so that other people that consume it can rapidly shift their perspective and start to unpick those findings. The 6 techniques I've gone through are, firstly, if you have a manually drawn set of cohorts, let's use machine clustering to challenge that. Let's try and find out how truthful that is. Secondly, if you've selected a point in time, let's use analytics over time to bring our worldview up to date and actually look at what the trends are. Thirdly, when you're looking at data over time, let's also spot test any hypothesis by drilling into, for example, specific measures as they develop over time and see how they develop. Fourth, when I am selective about what metrics I use in a visualization, let's be honest, let's expose the metadata about all the other metrics that we have. Let other people choose different metrics that may be more relevant to their domain of expertise. Fifth, we've said that whenever we put a trend line on a chart, it would probably be useful if we give people an easy way to explore the residuals to see how valid that trend line is or whether or not that trend line in itself exposes some bias. And finally, we've spoken about the impact of part-to-whole analysis. So enable people to look at trends as well as looking at the outliers, but then analyze for example, a specific country in proportion to what is going on around it and arrive at some better decisions based on that. Okay, so thanks for watching, and I hope this was relevant to you. If you're interested, I will follow this up with a longer click-by-click how-to walkthrough, which will show how we created each of the visualizations in this talk and look at some of the underlying analytic concepts. Thank you.